Okay, last Stoic video. I'm going to do these last few examples in the notes, and I'm going to go through them pretty quickly. They pretty much are the same pattern as we've been doing so far. You can use a roadmap, very similar to one we used before. There's going to be a few little differences. If we look at question number 4 in the notes, it says how many molecules. Question number 5 says how many liters. Question number 6 says how many atoms. That's it for questions. If we go back up to our roadmap, basically any of those units I just said, molecules, atoms, or liters, we can substitute in for grams. So when you set up our roadmap and we're trying to get to molecules or atoms or liters, we're just going to put that unit in the grams spot. So let's do that. Number 4, I think it was. How many molecules of H2O can be made if we react 4.7 moles of O2 with excess hydrogen? So I'll balance the equation, then I'll set it up, and I'll set up, or I'll start to set it up. I'll set up the map, and maybe I'll do this one completely. Let's see here. We got H2 plus O2. I'm going to put a 2 in front of that, which means I want to put a 2 in front of that. 4 H's, 4 H's, 2 O's, 2 O's. Okay, so that's our balance equation. If I set up my map, grams, 2 moles, 2 moles, 2, instead of grams, I'm going to put molecules here. Moles and molecules are two different things. I'm starting at moles of O2, because my starting number, 4.7 moles of O2. And I'm trying to get to molecules of H2O. So if I look at that, that's going to be a two-step question. Since I have moles, I can use my recipe right away and go from moles of O2 to moles of H2O, because I'm looking for H2O. And we can see that on our map. Moles of O2. The next stop on our map is moles of the other chemical, which is in this case H2O. So moles H2O times blank line again, because we got another step to do. Top unit always on the bottom. So our moles of H2O, and then we can go to molecules of H2O. Now, just like before, moles over moles, we look at our balance equation. Well, in front of H2O, there's a 2. In front of O2, well, there's no number. There's actually a 1 there. I'm going to put a 1 there. Now, moles, when moles is with grams or molecules or liters or atoms, mole is always 1. It's just when moles and moles are together, there's something else. You look at your balance equation for them. Any other case, mole is always 1. So molecules, if I look back in my notes, I'm going to use Avogadro's number. So I'll do 4.7 times 2 divided by 1 times 6.022 times 10 to the 23 divided by 1, and that'll give me my answer. When I do that math in my calculator, I get 5.66068 times 10 to the 24. Again, if you don't know how to plug this number, 6.022 times 10 to the 23, if you don't know how to plug that into your calculator, stop by and I can show you. Now I want sig figs, so 2 sig figs, cut it off there. That's 6, makes that into a 7, so 5.7 times 10 to the 24. Don't forget about that, it's part of the number. That cancels that, that cancels that. So we're left with molecules H2O. And that's good because the question's asking for how many molecules of H2O. So again, very similar setup. It's just a little bit of change in the roadmap because we're substituting molecules in for grams. I will do the next one here. So yeah, there we go. Next example, I'm going to pause it, set all this up, talk about it real quick, then show you the answer just to save a little bit of time here. So I balance the equation here. 6H's, 2N's, 2N's, it's all balanced. Then I set up, starting number, 2.3 moles, N2. I set up my roadmap to figure out where I'm going. I'm starting at moles of N2, and I'm trying to get to liters of NH3. Again, liters I substituted into that grams spot. So my first step is moles of N2 to moles of NH3, and that's what I see here, moles N2 to moles of N3, NH3. My second step is moles of NH3 to liters of NH3, and that's what we're doing with this conversion factor, moles of NH3 to liters of NH3. And just like before, I have that diagonal down to the right pattern. Moles N2 is going to cancel moles N2. Moles NH3 is going to cancel moles NH3. We'll be left with moles NH3, which is what we're looking for. Now just a matter of what numbers to fill in these spots. Moles over moles, look at my balance equation. That's a 2 in front of NH3, N2, there's no number, which means there's a 1. Liters and moles, again with moles is with anything other than moles, it's always 1. And liters, if you look back in your notes, is 22.41. So I'm going to pause it real quick, do that math, show you the answer. If you want to pause the video, do the math, and see if you get the same answer, might be a good idea. So I did the math, I get 103.086. Now this is a little bit tricky, I want 2 sig figs, so I'm going to cut it off here. That 3 isn't going to change the 0. So the only way to write this with 2 sig figs is in scientific notation. Move the decimal point over 2 places, so that's where this 2 came from. So 1.0, those are my 2 sig figs, times 10 to the 2 liters of NH3 is my answer. So that is example number 5. Again, similar pattern, just replacing liters into that gram spot. And I'm going to do the last one here. And again, if you want to pause the video now, I'm going to set it all up. I'm going to pause the video, set it all up, show you the answer. So why don't you pause the video, try this on your own, and then you can check your answer. And when you're done, unpause the video. So here's the basic setup. We have the balance equation. I wrote up my roadmap. We're going from grams of Na2O to atoms of Na. And here's what your setup should look like. I haven't filled any numbers in. I'm going to pause the video, and you should also pause the video. Finish this, and then you can check your answer. So when you're done and you have your final answer, unpause it, and you can check your answer against mine. Okay, there we have it. All the numbers filled in, and you should have gotten an answer of 4.86 times 10 to the 23 atoms of sodium. I'm looking at the setup here. Moles and grams are together, so mole is 1. Mole and atoms together, mole is 1. The 2 moles together, we always look at our balance equation. 4 moles for Na, 2 moles for Na2O. The 61.97 number I got from adding 2 Nas and 1 O. So I found the total for the red numbers, the masses, for Na2O. And in front of atoms, I always put 6.022 times 10 to the 23, like the note said. Do the math, and sig figs and units. So hopefully those examples will be of use to you. If you get stuck on if you get stuck on the practice quiz, there is only one Stoich practice quiz on the Moodle site. If you get stuck on that, go back, look at the notes, watch one of these videos, something like that. And if you still can't figure it out, stop by and ask me questions. send me an email if you have any questions. Stop in before or after school or during one of the off days. Any of those times are great. Talk to you later.